Hello everybody. Today's lecture is about sodium borohydride. So another existing agents for using the metal hydride reactions. Sodium borohydride is a milder reagents as compared to lithium aluminum hydride. So sodium borohydride it is available commercially. It is available commercially. But it can also be prepared in the laboratory. It can also be prepared in the laboratory. It can also be prepared in the laboratory by reacting with. It can also be prepared in the laboratory by reacting with in the laboratory by reacting with sodium hydride in presence of sodium borate. Okay. In the laboratory by reacting sodium hydride with methyl borate with methyl borate at elevated temperature means at higher temperature at elevated temperature. So reaction is sodium hydride reacts with methyl borate OCH33. So to keep in high temperature around 250 degrees Celsius to get this sodium borohydride and this sodium methoxide. So you can have this three. So you can have three. This is 4 and it's okay. Balance like this. So I'm repeating again. Sodium borohydride is available commercially. It can also prepare in the laboratory by reacting with sodium hydride with methyl borate at elevated temperature. Another reaction is sodium hydride can react with boron. This is boron. So you get sodium borohydride. Okay. So another reactions. So but sodium borohydride is a milder reagent as compared to lithium aluminum hydride. So we can compare sodium borohydride with lithium aluminum hydride. Lithium aluminum hydride, as we have discussed earlier, is a very strong reagent as compared to sodium borohydride. So comparison between lithium aluminum hydride and sodium borohydride. Okay. So first point is that sodium borohydride is selective in reduction selective. So that means that it can reduce only the carbonic compounds. Other functional groups are not reduced by sodium borohydride. Say nitrile, nitro, etc. are not reduced by sodium borohydride. But in the case of lithium aluminum hydride, it can reduce almost all the functional groups. Almost all the functional groups are reduced. Okay, functional groups are reduced by lithium aluminum hydride. But in the case of sodium borohydride, only carbonic compounds are reduced, so it is selective. And second point is that sodium borohydride is much milder reagent as compared to lithium aluminum hydride. Lithium aluminum hydride is strong reagent, but in the sodium borohydride is a milder reagent. And third point is that sodium borohydride reaction of sodium borohydride can take place in the protic solvent also protic solvents. But lithium hydride cannot take place in protic solvents because they are used in the anhydrous conditions. So there is a difference between these two anhydrous conditions, because in presence of water, lithium aluminum hydrides are decomposed So that's why they using lithium hydride gas. They using DHF, tetrahydrofuran, or in ether. Okay. But in the case of sodium borohydride, can be used in protect solvents, for example, ethanol, isopropanol use. That's why sodium borohydride reaction takes place in carbohydrate chemistry. So I will give some examples about the reactions of use of sodium borohydride. Okay, so we can have some examples I will give. So like acetylacetone, acetyl, acetone, okay, CO, CH2, COCH3. So in presence of sodium borohydride, followed by hydrolysis, so this will give this ketones are reduced to secondary alcohol, CH2, CH, CH3. Okay, so acetyl acetone. So these carbonyl groups are reduced to alcohol, secondary alcohols. Another example is let's say glucose. Glucose is CHOH 3, okay, 4, and this is glucose. So in the carbohydrate chemistry, they can use sodium borohydride in aqueous ethanol. So in presence they can give sorbitol. So all these aldehydes is reduced to primary alcohol, CH2OH. This is called sorbitol. So it is used in carbohydrate chemistry. So these aldehydes are reduced to primary alcohol. So this is what. So again, sodium borohydride is reduction takes place only carbonic groups. Other functional groups are not reduced. I will give some examples. So only carbonyl groups are reduced by sodium borohydride. Other functional groups are not reduced. Functional groups are not reduced by sodium borohydride. So I'll give you some examples. Okay, here I'll give some examples. So like in presence of double bond, like cinnamaldehyde, CH double bond, CHO, cinnamaldehyde. So in presence of sodium borohydride, then reduce in presence of ethanol. So you can reduce to double bonds are not reduced. These only this aldehyde group is reduced to alcohol. Okay, primary alcohol. Similarly, in presence of cyano group, so CH2, CHO. Okay, so 3 from 1, 2, 3 cyano propanaldehyde. So in presence of sodium borohydride, you can use only this aldehyde groups is reduced, and the nitrile groups are not reduced. So CH2, CH2OH. So this to primary alcohol. So not even nitrobenzaldehyde. Nitro groups are here, benzaldehyde. So many examples are here. So only this what I want to say. Nitro group is not reduced, and only the aldehyde group is carbonyl group is reduced. Okay, so it is a selective reduction takes place. So milder reactions. So many examples are here. So we can have many examples. So in the presence of ester also we can have. So esters are not reduced, but in the case of esters are not reduced. But in the case of lithium hydride, esters also reduced. But here sodium borohydride, only the carbonyl group is reduced, and not the ketonic group is reduced. Okay, not esters are not reduced. So this is why they are milder reagents. So these I am giving some examples. So in presence of other functional groups, only the carbonyl groups are reduced. So aldehydes are reduced to primary alcohol, and ketones are reduced to secondary alcohols. So now let's see the mechanism of the reactions. So in the case of mechanism of the reactions, as you know, this sodium borohydride contains 4 hydrogen atoms. So all the 4 hydrogen atoms can be utilized to reduce all the 4 molecules of carbonic compounds. So reaction takes place, generally reaction sodium borohydride reaction takes place in ethanol or isopropanol. So let's say some examples in presence of ethanol. So let's see the mechanism of sodium borohydride reactions of carbonic compounds. So reaction takes place in presence of isopropanol. Okay, since CH this isopropanol, and this is the sodium borohydride. And this is the negative charge, and then again we have the three carbon groups here, carbon groups like ketone. So let us say RR. Okay, general one R. So here migration takes place. So sodium borohydride attacks this here carbon atom of the carbon group and pick up this hydrogen atom and then come like this. Okay, so reaction takes place this way. So first step is this one is ketone is reduced to RR CHOH. Second alcohol pick up the proton here, pick up hydride transfer from borohydride, and then pick up this one. So OH come, and this plus this we have this complex I stray B bond negative charge here linked with the oxygen or CH. So you can take two methyl groups, sorry, Me2. Okay, so this can react with another ketonic group. This they can, because it contains three here, so they can utilize another carbonyl groups R2 ketone. So you can reduce this one, so they can reduce to R2CHOH. This ketone reduced to like this one, reduced to second alcohol. Then you got this will be 2 number of hydrogen atoms reduced, decreases. So we have OCH Me2, this 2. Okay, so negative charge here. So similarly, this again be utilized another. You can use, so you can again reduce another ketonic group, carbonyl group ketone. So here you can have, so like this. So you can have ketone reduced to alcohol, second alcohol plus HB. So the number of OCH Me2 3. Okay, yeah, increasing this one, increasing to a number of hydrogen atoms. So finally this also can again react with another carbonyl group to give this. So yeah, it used to, so 4 hydrogen atoms are utilized to give this one. OCH Me2 4. Okay, so like this. So you got four molecules of ketones are reduced to 4 primary secondary alcohol. So this is the mechanism about the reduction of sodium borohydride by this one. Okay, so this reduction of sodium borohydride using sodium borohydride can be modified by using some metal salts also. So next I will tell you about the modification of sodium borohydride reaction by using some metal salt, mostly anthanite salts. Okay, so I write here sodium borohydride reduction can be modified. Condition can be modified by taking some metal salts, so like lanthanide salts. Okay, lanthanide salts, mostly lanthanide salts. Say for example, sodium chloride. Okay, so here if we use sodium chloride reaction of with sodium borohydride, that can undergo selective reductions. So the carbonyl groups which has less stable will be reduced. So for example, I will give one example here. Say, okay, here this steroidal ketone here. Okay, this here we have 2 carbonyl groups here. Okay, this steroidal ketones. So one is here, one is another carbonyl here, alpha beta unsaturated carbonyl compound, and the one here. So here this is less stable because of presence of the conjugated system. So here this carbonyl group is reduced by sodium borohydride. So ethanol in presence of sodium chloride. So 6 water crystallization. Okay, so this will This will be not reduced, this will be reduced. So the product will be like this. So this should not be, so this one will not be reduced. Okay, only this one is reduced to alcohol. So like this. So here, so what I'm telling that selective reduction can take place. So two carbon groups are here, so it can be selective reduction can take place by using this so metal salts. Okay, another example, say I'll give another example for embroidering. So here another one is carbon aldehyde group, another one having this ketonic group. Okay, two methyl groups are here. So here same case, sodium borohydride in presence of ethanol and sodium chloride 6 molecular water catalyzation. So you can give some similarly here also followed by hydrolysis. So here also aldehydes are not reduced, only the ketonic group is reduced. Only the ketonic group is reduced. Okay, CSO and this OS is okay. So here selective reduction takes place in presence of metal salts, methanide salts. So this is a modified form of sodium borohydride reactions. Many examples are here. So I'm giving this. Okay. So this is about the sodium borohydride reactions of carbonic compound. It is very selective. They cannot reduce almost other functional groups are not reduced. But lithium hydride is very strong reagents. They can reduce almost all functional groups. Now we can have another reducing agents using called Meyer-Wine Pondorf reductions. So here in this case, aluminum isopropoxide is used. So we have another name reactions using CMN called Meyer-Wine Pondorf reductions. So here also transfer of hydride transfer takes place, but here reagents uses aluminum isopropoxide. So here carbonic groups, there's a ketones. Okay, ketones are used in presence of aluminum isopropoxide OPR. See here isopropoxide 3. Okay, in presence of isopropanol okay, for hydrolysis, acid hydrolysis takes place. Okay, so this will give these ketones are reduced to secondary alcohols. Okay, like this. So here present plus got a from isopropoxide got acetone of 10. Okay, so it's a byproduct. So this is about the reduction of carbonic compounds or ketones in presence of aluminum isopropoxide by aluminum isopropoxide in presence of isopropanol followed by hydrolysis to give secondary alcohols or primary alcohols is known as Meyer-Wine Pondorf reductions. Okay, so I'll give some examples about these reactions. Okay, reaction is very simple. Reaction takes place just by heating all the reaction mixtures together by heating. Say here we got ketones, then isopropoxide is 2CaO. So here we can have 3 aluminum isopropoxide, and then we have isopropanol CH3 2CaOs. Then in presence for hydrolysis, so we got this ketone will be reduced to secondary alcohol. Okay, so I'm giving acetophenol by reacting with aluminum isopropoxide in presence of isopropanol. Get this one. Another example is benzophenol. Also you can have COC6H5 phenol. So here aluminum isopropoxide OPRI3, then isopropanol OH I isopropanol followed by hydrolysis will give this phenyl group, this alcohol, secondary alcohols. Okay, So this reaction is used for reduction of ketones or carbonic compounds with eliminate superoxide in presence of isopropanol. So this is called Meerwan-Ponto reductions. So the mechanism, I will see the mechanism of the reactions. The mechanism of reaction takes place, hydride transfer takes place from the isopropoxide group. So here mechanism, I will give the mechanism of the reactions. Mechanism. So here, so we have the ketone, and this R prime. Okay, then aluminum isopropoxide, we have OCH. So this is two methyl groups are here, Me2 OCH, Me2, two methyl group. Another one is OCH. Okay, let's say methyl groups are here. This is aluminum isopropoxide. Okay, OCH, there are good three groups are here. So first step is so transfer of hydride from the isopropoxide group takes place here to the carbon atom of the carbonic group, and come like this, and this go like this. Okay, loss of stone takes place. So reaction takes place through a 6-member cyclic system transition state. Okay, so we can have the reaction takes place through 6-member transition state. So here I will draw here this aluminum. Okay, so OCH Me2, OCH Me2, then we have okay, here O, then this hydrogen here, this C Me here. Okay, so this 6-member transition state takes place through this one. So the product is, final product will be, so first this will be ketone will be reduced to alcohol, or is no first will be, I'll get the product. This will be first we'll get the acetone here. So we'll get the R C R prime O aluminum here, 2 AME here, OCH Me2. So you can write this 2 here. Okay, then the hydrogen here, CH. Okay, plus this could be the acetone here. This is acetone. So you can write CH3 to CO. This is acetone. Okay, so we got this compound. First this complex, then this complex will hydrolysis with water. We'll get this alcohol hydrolysis with water. We'll get this alcohol. Okay, OH R prime R. Okay, alcohol, we got to hydrolyze this one. So we got a product. So this is the mechanism. The mechanism takes place through Meerwan-Ponto reduction mechanism takes place through a 6-member transition state. So here acetones is left, and these ketones are reduced to secondary alcohols. So here also similarly like earlier one, sodium boride reaction. So only the carbonic groups are reduced, other functional groups are intact. So it is selective. So I will give you some examples. This Meerwan-Ponto reduction is very selective. It reduces only the carbonic groups. No other functional groups are not reduced. For example, I will give you cotonaldehyde, CH double bond CH, CH3, CHO. This cotonaldehyde. So using Meerwan-Ponto reductions. Okay, only this aldehyde groups are reduced to primary alcohol. So these double bonds are not reduced. So only the carbonyl groups, that is here aldehydes, are reduced to primary alcohol. Similarly, you can have phenyl, then cinnamaldehyde to same one. We have Meerwan-Ponto reductions using aluminum isopropoxide in presence of isopropanol, followed by hydrolysis. We'll get this reduction product. So only the aldehydes are reduced to primary alcohol. So I'm repeating again here. So cotonaldehydes are reduced to cortyl alcohol, and cinnamaldehydes are reduced to cinnamoyl alcohol. Similarly, you can have like earlier cases, say nitrobenzaldehyde. There are nitrobenzaldehydes. para-nitrobenzylaldehyde also. Only the aldehyde groups are reduced using MIR1 bond of bar reductions, that is reduction using aluminum isoproposite and aluminum isoproposite presence of isopropanol, and followed by hydrolysis will give this aldehyde groups are reduced to alcohol. Okay, so other functional groups are not reduced. So another example is steroidal compound. Steroidal compounds, I am giving one examples. Wisterone, this is called wisterone. Wisterone. So here, so wisterone. This is wisterone. Wisterone, okay. Wisterone, so undergo MIR1 bond of Barley reductions. So only this is reduced. So carbonyl group is reduced. So it gives product will be, it is intact. So here intact. So here OS group here. Okay. So this is carbonyl group reduced. So this is called oestradiol. Okay. So what I'm telling here is that MIR1 bond of Barley reduction also undergoes selective reductions. Only the carbonic compounds are reduced, other functional groups are not reduced, such like sodium borohydride. So in the case of MIR1 bond of Barley reductions, the aluminum isoproposites in presence of isopropanol followed by hydrolysis takes place. So these reactions about this metal hydride reactions. So we'll take next class. We'll take about the hydroborations and other reactions. Okay. So we'll take. You cannot see this one. I think that last one you can miss out. I'll show you last one. You cannot see that. Okay, I write again. Okay. Yeah, because it's not coming here. Sorry. The last one I will show here. Okay. The last one was steroid. So this is a steroid. So this is carbon groups. OS. Okay. Histones here. So here using MIR1 bond reductions. So using aluminum isoproposite in presence of isopropanol followed by hydrolysis. So this is reduced to, it don't reduce to alcohol. Okay. So this is the, so you can see the last one. Okay, I'm writing here again. Okay. So this is called oestrone and this is called oestradiol. Two alcohol are here. So what I'm telling you that selective reduction takes place. Okay. So this is about today class. So next class I'll take up hydroboration, then 9 dBA and extra. Okay.